I was thinking we were going to have a lesson or questions first. Okay, so we've got angle for similar triangles. The next one would be side similarity. Let me show you a couple of triangles here. Let's say this is 3, and this is 6, and this is 4, and this is 8. What do you think about those two triangles being similar? What do you think about those two triangles being similar? Is side enough? No, it isn't, is it? You know, this one, I could have a side here that's 3, and then I could draw this side over here and make it 4, so that it's still in proportion side, but the third side is not going to be proportional, isn't it? Or is it? So in order to have two triangles similar, we have to have side. We have to know that all 3 pairs of corresponding sides are in proportion. And you can just see that, can't you? You can see that 2 is just not going to get it done. So let's look over to page 437. Okay, so let's say we're given that triangle ABC is similar to triangle DEF. Okay, so we need to find the value of x here, knowing that these two triangles are similar. When you look at these two triangles, what's the key here? What's the part of them that you're noticing that you're going, aha?
The 4 and the 12.
Yeah? You guys all agree with that? It's the 4 and the 12, isn't it? Okay? The 4 and the 12, that's great to know. We know the scale factor from ABC to DEF is 3, correct? Mm-hmm. Okay? So let's see. I could do it this way. I could say, look, 8 times...
3.
All right, there you go. 8 times 3 has got to equal 3 times x plus 1. What about x subtract 1? X subtract 1 multiplied by 3 equals 18. Now that's great when the scale factor is a nice integer, whole number. Now if the scale factor is 5/7 or something not so pretty, right? Then we could have a little bit of a more difficult problem. So most of the time you're not going to be able to just look at them and say, well, you know, 8 times 3 has got to equal this right here. So I still think, though, we can do the 4 over 12. 4 over 12, that's our ratio, isn't it? Do I have that up high enough? 4 over 12 has got to equal x subtract 1 over 18. And what's the other one? Come on. 8 over, yeah, and you say 3 times the quantity x plus 1. Okay? Now, here's the thing, guys. We can't solve all this at once. Okay? You just have to say, look, can I solve that? We can solve that. Could we solve this? I can. You probably can't, because we're going to get x squared. That's probably not what we want. We don't want a quadratic equation. You guys aren't going to be able to solve something where you have x squared yet, unless it's super simple, like x squared equals 9. Can you guys solve that one? What number squared equals 9? Okay. What about negative 3? Would that work also?
Yeah.
Would that work in... So x could be a negative 3 as long as it doesn't make the length of a side negative. So sometimes you can get a variable in a geometry problem where it's a negative number. But you need to make sure it's not making one of the sides negative. Anyway, here's the thing. If I ignore that bit, okay, we can solve this. 12x subtract, 12. Now subtract 1, subtract 12. This is, there's parentheses around that fraction line. Equals 18 times 4. Isn't that 40 plus 24? Yeah? Okay, we can solve this for x. So we can add 12 to both sides. 12x equals 72. 72 divided by 12, isn't that 6? Okay. So that would make this side right here 5. And it would make this side 6 subtract 1, which is 5 times 3 would be 15. That working? It's what? Say it again.
It's not what we got. It's like 72. We got like 64.
So
yeah, 4 times 18 is 72.
what if we solve it this way? 12 times 8, isn't that 96? And then 4 times 3, that's 12, times x plus 1 is 12x plus 12. Subtract 12 from both sides, isn't that 84? Divide both sides by 12. X equals... Does that work? That's not the same x, is it? It's not the same x. So that's what was looking at when I did this problem, and I'm like, why am I not getting the same x here and here? Why would that be? Can these two triangles be similar? Can these two triangles be similar if that's the case? No. So then I reread the problem. And this is something that I ran into last year about 3 different times with kids. The statement says, are the two triangles similar? And we read the statement as they're similar. And then we just look at them without reading the instructions and say, what's x? And we try to figure out what x is, right? But depending on how you solve for x, are you going to get the same answer? Are you? Why not? Because they're not similar, right? So everybody turn over to page 441. Look at the instructions right above number 3. What are we doing there? Okay, are they similar, right? Okay, now look down below above number 5. Okay, what does x have to be in order to make them similar, right? So in that case, you have to say, okay, well, I'm going to assume they're similar and solve for x and say, well, that's the number x has to be in order for this to happen, okay? So I want you guys to be very careful about reading these instructions today. And on the test, okay, you need to be very careful about reading them and saying, okay, what do I really know and what am I trying to prove? That make sense, Chase? You happy?
Yeah.
All right. Okay. So down to the bottom of page 437. There's 3 triangles. Which, if any of them, are similar? How can you tell? I mean, how do you even know which sides to compare? And
You have to compare the shorter sides to the shorter sides.
okay, so the first one we got 20, the next one we got 24, the next one we got 36. So 20 over 24, does that reduce down? 5, 6. 24 over 36, does that reduce down? 4 goes in both of them, doesn't it? That goes down to 6 over 9. So is that the same ratio? No, sorry, 24 over 30. 24 over 30. That would be 6 over... Okay. So, what about the medium ones? 24 over 30. Okay, so how about this? Look at the 2 triangles on the left. Short side over short side should equal medium size over medium side, which should equal the longest side over the longest side. If those 2 triangles are in fact similar, all 3 of these fractions should be equal, right? Okay, are they? Kimball, you shook your head. Okay, so we can see some problems, can't we? This one reduces down, 4 goes in here, 5, 6. Hey, Willie.
Notebook.
No, it's actually the laptop that they got me for computer science stuff. And I ran the diagnostic on it, and it says that the piece of hardware is not working.
Say what piece of hardware?
Yeah, it does. I can't remember what it's called though. There's no.
Qualcomm, your wireless.
Let's see. 6 goes in here. 4 times goes in here. 5 times. This one doesn't even reduce down very well at all, does it? Okay. So we're not getting the same ratio all the way across. But what about the little one and the big one? Does it work? Or is it the 2 on the right? The middle and the right one? Come on. Which 2 is it? Middle and right? Let's see. Short side, 24 or 20? Over short side, 30. Well, that's a nice little ratio, 2 to 3. That's easy, right? 24 over 36. 26 over 39. All 2 to 3. Simple enough? Okay, so the 2 triangles are similar. And what's our reason?
Because they're
Side, side, side. Yeah, side, side, side. There you go. Okay? All right, now. Here. I want you to watch carefully and tell me what you think about this situation. Let me go to centimeters here. Let's go 5 centimeters. Get one of those that has all the parts to it. Let's go 60 degrees, and then let's come out here 4. 60 degrees, 4 centimeters, 5 centimeters. And now let's go 10 centimeters. 60 degrees. And guess how many? There you go. 8 centimeters. So 8, 10, 60 degrees. when I make this connection, similar or no? Yeah. What are we going to call this one? Side angle side. Now it's a little weird because the sides are proportional, but what about the angles? Yeah, they're congruent. The angles are congruent. And does it have to be the included angle? Can't just be any angle, can it? Right? Okay. So there's our side angle side similarity thing. Let's look over on page 438. There's a horrible, horrible shelter that would be the worst thing I can possibly imagine trying to sleep in out in a rainstorm. What do you think? Are the two triangles, looks like it's built on a hillside or something, so it's sloping off. That way you can roll over in your sleep and accidentally roll off down the hill and get rained on more, right?
I think if you're rolling down a hill, getting rained on is probably the least of your concerns.
Which would be worse, getting rained on or rolling down the hill in the middle of the night when it's cold? I've been to a few scout camps like this. Anywho, 6:10:53, 9:15:53. What do you say? Is 6/10 going to equal 9/15? Are they ratios working?
Yeah, they're both 3/5.
Okay, they're both 3 to 5. Okay, so they both equal 3 to 5. And the included angle, is it working? Okay, so they're similar, aren't they? Okay. Now, the nice thing about that is, even though one is longer than the other one, this roof line up here, can you keep that level? You can. And so you can keep that level and you can keep the water running off that without tipping it over the edge and getting on you worse than normal. Although that's just got a bad night's sleep written all over it, doesn't it? How about all the water runs off this way and then runs underneath your sleeping bag? If you have a sleeping bag, you're not on one of those freaky shows, right? All right, guys, it must be Monday. I've barely pried 3 words out of you. Okay, what do you want to do? Basic, average, or advanced? Advanced it is! I need to hear some enthusiasm from you guys. Do they sound enthusiastic about that
They don't
basic?
make it sound asleep.
I know. I think you guys need more. Here you go.
I'd give them a test. See if that works them out.
We've already done this assignment.
Yeah, you see.
You've already done 8.3?
Yeah. We have?
We haven't talked about it.
Yeah, we didn't finish it.
Oh. You don't have it all the way done, do you, Yost? I think so.